Okay, the next step is going to be for us to actually apply some force to the particles. At this point, we only have them being emitted with different velocities, and it gives some interesting shapes overall. But as you can see, they kind of develop in a linear fashion. All particles are kind of being emitted on one direction, and they're not being affected by anything else. So let's work on that. And the way we're going to do that is by using one of the most common forces. We're not going to be needing this merge here, so I'm just going to remove it. One of the most common forces that you'll use in POPs is pop force. And pop force has a noise included. For us to have an easier time at actually visualizing the effect of this, let's go outside for a moment and let's remove the noise from the velocity. If we remove the noise from the velocity, you'll see that they go just straight. Okay, just straight. The shape variation that we see here is just from the animated density attribute, okay? But it'll be easier for us to actually be able to see what that force is doing. So let's go inside, let's connect the pop force here. We don't want to push it in any particular direction. We just want to apply some noise to it. So let's start with an amplitude of 1. And the swirl size is also something that we need to consider, or at least take into account the scale at which we're working. So let's, because our sphere is rather small, let's go with 0.1. I think it'll be more appropriate to this. And let's see what's happening. Let me get some room. So still not the easiest effect to see. Let's try and put the swirl size a bit bigger, 0.2, maybe that'll help. Okay, so now we should be able to see. One thing that we can do, just for the sake of clarity, let me just kind of override this and let's set, let's disable all of this. Let's just create a velocity pointing up. Let's say that velocity is going to be equal to a vector 0, 1, 0. So now our particles are only being pushed up, and we can see the effect of the noise much easier. Okay, this is how much the noise is affecting the particles. Let's dive inside and let's play with these values. So I think an amplitude of 1 isn't bad. The swirl size might be a bit too big. I might also want to have a bit less speed here, 0.2, just so we can see it clearly. Okay, so this is the noise. Looks cool, right? I think it is, these values, the values that we're using, are actually working pretty well. Maybe a bit too strong, maybe a bit too big for what I'm going for. I would like these swirls to be kind of probably half size. So swirl size 0.1 and amplitude 0.5. Yeah, maybe this. Okay. The other thing is I want to kind of be able to control how much the particles get away from the emitter. I don't want them to kind of have too much freedom and expand too much. So one way we can control that is by applying another very common force, which is a drag force. So pop drag. And this is basically some, as the name implies here, air resistance. So this is how much air resistance we're going to be adding to the simulation, and this is the velocity that's going to be matched by this pop track. So if you actually add some velocity here, instead of them stopping, they will be progressively approximating to this velocity, but I actually want them to stop pretty much. So let's see here. So This is the size at 72, and let's increase this to 10. And as you can see, it doesn't expand as much anymore. Okay, so this is definitely a cool tool for us to use here. So I'm going to turn back on all the features. So let's turn this back on. Let's hide this one, and let's see how this is working. Definitely an interesting effect. As you can see, as they expand, they kind of slow down before disappearing. One thing we can do is we can actually kill them sooner as well. So let's go to the source, maybe 0.6, 0.3. Now they die a little sooner. And I think this is a good approach. The initial velocity might be a bit too much, so that's something we can also scale here. Inherit velocity. Let's start with 0.2. Okay, this is getting closer to what I was going for. Maybe it's still a bit too much, but I kind of like this shape at this point. Pretty interesting kind of emission going on there. Okay, definitely something interesting to go with. Okay, I'm going to try something else outside that'll should make it easier for us to actually visualize what's happening. And that is to kind of process the information on these points. You don't actually need a DOP import. You can use a DOP import, that's fine. But because the DOP.NET already has a section of object merge, you can just isolate the object that we want. And in our case, it's pop object 1. And that's just going to show, probably wrong, pop object not 1. Usually there's a number there, but in this case there's not. Okay, and we can just process directly from here. And basically what I want is to have a color gradient based on the speed of the particles. So let's kind of normalize the speed based on the velocity. I'm gonna actually keep that attribute float and our speed norm equals the length of the vector velocity divided by some maximum velocity, which I don't really know which one it is. Max speed, not velocity. So velocity will be a vector. Speed will be the length of that vector, how fast it's going. Doesn't take into account any type of direction. That's pretty much the difference. So this will give me the speed norm, and then we can have the color be determined by a channel ramp called color ramp. Oops. Color ramp based on the speed norm. So we do need to imagine what the maximum speed will be. Let's go to 0.1. I have no idea. And also the type of ramp that we want is not a float ramp. It's going to be the color ramp is going to be color accept. And let's set this to something weird. So let's say it starts white, goes into blue, and then goes into something more magenta. Okay, let's see how this works. A bit too chaotic. So 0.2. Okay, not bad. Maybe this is a bit too crazy of a combination of color, but so white will be when they are very slow, and when they're faster, they're gonna go all the way up to magenta. I think it's cool. Let's try increasing the number of particles, by the way. Here on the birth, let's go to 10, double. Okay. Still pretty fast. Yeah, I think we get some interesting texture and color variation there. Maybe I'll call this color by speed. This should make it easier for us to kind of figure out what type of velocities we're having. Yeah, I think it's an interesting shape.